For as long as we've been able to look up, we've stared at that little red dot in the night sky and just wondered. But today, today we're doing a lot more than just wondering. We are getting closer than ever to a real answer. So let's dive right in.
I mean, this is it, isn't it? The big one. The question that has launched countless missions, cost billions of dollars, and fueled the careers of thousands of scientists. And for a very good reason. Because the answer, no matter what it turns out to be, literally changes everything we thought we knew. And that's what brings us here today. A recent analysis, a deep dive into a rock sample drilled by the Perseverance rover, has the entire scientific community buzzing. Now look, it is not definitive proof, but it is, without a doubt, the most compelling piece of evidence we have ever found. So, what in the world did our little robotic geologist actually find up there? Let's break down this incredible discovery. Okay, so here's the thing. Any one of these points on its own wouldn't be a smoking gun, but when you put them all together, that's when they start to tell a really powerful story. So the Perseverance rover found this rock in what we know was an ancient lake bed, Jezero Crater. It's got these really unique textures, it has organic carbon, the building blocks of life, and a very specific mix of minerals that here on Earth are often linked to biology. And all of this is in a rock from a time when we know for a fact Mars was a water world. Now, to really get why this one rock is so incredibly significant, we kind of need to zoom out for a second. See, this discovery didn't just happen in a vacuum. It's the potential peak of a logical, step-by-step hunt that's been going on for decades. This right here, this is the scientific method in action, perfectly laid out. You don't just trip over alien life. No, first you have to prove that an environment could have supported life in the first place. Then you look for the raw materials, the ingredients life needs. And only then, after you've checked those two boxes, do you start the real search for biosignatures, those direct signs that life might have actually left behind. And for years, we've been successfully checking off those first two boxes. Our orbiters and rovers have given us just undeniable proof of ancient water. We can literally see the dried-up river deltas from space. And our rovers on the ground, both Curiosity and Perseverance, have confirmed that organic molecules, the basic ingredients, are there in the Martian soil. So check and check. Mars had the right environment and the right ingredients. All right, so with all that context in our back pocket, let's dive back into this special rock, the Cheeva Falls sample, and really decode what makes it such a compelling clue for step 3 of our search. First, we have to get this definition down because it's so important. Scientists are calling this a potential biosignature. That phrase is key. It's science speak for, hey, this looks a whole lot like life, but we haven't been able to rule out every single other non-biological explanation just yet. It's the language of cautious, careful, rigorous science. This slide really gets to the heart of it. The specific minerals they found, vivianite and greigite, are a big deal because here on our planet, they're often the leftovers from microbes living in ancient lake environments. And that leopard spot texture, also very striking, because it looks a lot like patterns left by microbial colonies here. But the real kicker is that the ingredients for life, that organic carbon, are all mixed in with these potential signs of life. They're in the same place at the same time. That's huge. So what does that mean in simple terms? Well, it means these minerals point to a kind of ancient chemical battery. Redox chemistry is all about moving electrons around, which is one of the most fundamental ways life gets energy. So we don't just have a nice place to live, we might actually have a power source for that life, preserved right in the rock itself. Okay, I know this all sounds incredibly convincing, right? So why isn't every scientist on Earth celebrating the discovery of alien life? Well, this is where that word potential in potential biosignature becomes so important. This is basically the mantra of every single planetary scientist working on this. The burden of proof for announcing you've found extraterrestrial life is, and absolutely should be, extraordinarily high. And here's the core of the problem. There are two competing explanations for what we're seeing in that rock. Yes, it could be ancient microbes munching on minerals, or it could just be geology, plain old water and chemistry. The way water flows through rock and deposits minerals can sometimes create these really intricate patterns that look an awful lot like fossils. Nature is a really clever mimic, and we have to be 100% sure we're not being fooled. So these are the hurdles we have to clear. To claim you've actually found life, you can't just present a good story.
You have to actively disprove every single other possible non-living explanation. And that is incredibly hard to do with the little chemistry set we have on a rover that's millions of miles away. The most sophisticated labs for this kind of work, they're all right here on our own planet. So, how do we clear those hurdles? What's the next move? And maybe more importantly, why does this painstaking, careful search matter so much to every single one of us?
Well, the answer is as simple to say as it is ambitious to do. To know for sure, we need to get our hands on these rocks. The next great leap in the search for life on Mars is a sample return mission to physically bring pieces of Mars back here to Earth for us to study.
And just think, if we get those samples back and our best labs on Earth confirm a biological origin, just take a second and think about that. It would mean life isn't some unique miracle that only happened here. It would suggest that the universe isn't sterile, but that it's actually predisposed to life, just waiting to spark wherever the conditions are right. It would completely, fundamentally, and forever alter how we see ourselves and our place in the cosmos. We would finally know we are not alone. And that, right there, that leaves us with the ultimate question. If it happened here on Earth, and it also happened right next door, on Mars, two separate starts in one tiny solar system, well then how many countless billions of times has it happened out there, among all those stars? That is the massive question that this little spotted rock from Mars is forcing us to ask.